Hello, my name is Sal Salas, and I'm doing my individual project on a single article that was done by an architect and civil engineer by the name of Ragab Khalil. He wrote about the accuracy of GIS tools for transforming assumed total station surveys to real world coordinates. Now, typical surveying, the total station is the go to instrument of choice, especially for topographic surveys where accuracy is, really needed. Now, when you're in remote locations in thick vegetation, in sparse environments, surveys tend to be performed in unprojected local assumed coordinate systems. Now, what does all that mean? Now that means that we're just limiting ourselves by being in an having unprojected survey grade data is like having a Ferrari with an engine from a Prius. We're just limiting ourselves. We need to find a way to merge the power of GIS and that survey data. Otherwise, our analysis becomes limited, and the value of those GIS data sets, like world imagery, elevation models, all those layers, they basically become useless. So how can we get that unprojected data into GIS so that we can exploit the power of those analytical tools? Well, transformations, of course. I'm not going to go into the matrixy math and all that in-depth um, math behind these transformations. The article does a great job of explaining um, all that stuff. But we're going to specifically talk about the use of the GIS spatial adjustment tool, the georeferencing tool, and a free add-on called the CHAMP tool. Now, CHAMP stands for Columbia Habitat Monitoring Program. We'll go over that in a second. All these tools use what's called an affine transformation. That generally just means that the transformation can consist of a rotation, a translation, scaling, and skewing. So why create the CHAMP tool? Well, like that habitat study in Colombia, which was trying to monitor the fisheries in the rivers, surveying was becoming a challenge due to the remote locations. The rough terrain and the thick vegetation made getting a satellite lock from GPS equipment very difficult. So a total station was used, and of course, an assumed coordinate system was utilized. So they needed a tool that could accurately transform that local unprojected data into a projected system that could be utilized in CAD and GIS. So, like I said, the CHAMP tool, along with the other GIS tools, uses an affine transformation. But the CHAMP tool specifically uses a simple affine transformation, which just takes advantage of a translation and a rotation. This left high accuracy with the data because the data was left unscaled and unskewed. They recommend 3 control points for the transformation, but a minimum of 2 can be used. Now, this picture here kind of gives you the basic concept of what the CHAMP tool does. You have your GPS control points or benchmarks. They're set up with the total station, but you'll also need projected coordinates on those same benchmarks, either with conventional GPS, handheld GPS, Google Earth, some kind of projected coordinate to go along with your assumed coordinates. So it'll take your assumed coordinates and it'll make the translation by matching it to your projected coordinates, and then it'll use a second benchmark. The first one will be sort of a hinge. Use a second benchmark and use that for the rotation. But that'll all be I'll go over that in more detail because I'll do an example of the actual CHAMP tool in GIS. Now on to findings and conclusions. So it looks like the CHAMP tool proved to be the champ. It caused the least amount of error using all the different control point sources. Now when I say control point sources, they use handheld GPS, Bing Maps, Google Earth Maps, and conventional GPS to get those projected coordinates on those benchmarks. Now, of course, the handheld Garmin GPS produced the most amount of error in all the different translations: a similarity translation, affine, georeferencing, which is basically just rubber sheeting, edge snapping, stretching. But the Champ tool proved to almost cause zero error in all four cases. The Bing and Google Earth control sets performed admirably right around the middle ground. So now I will show you the actual Champ tool in action. I'm going to quickly go over the Champ tool. There is a survey that was done on a Riversite. I'm going to import it here. It's unprojected, as it's telling you there's an unknown spatial reference. But if I zoom to the layers, you can see that it looks like your typical topographic survey. The only problem is these are assumed coordinates. And what I mean by assumed coordinates is, as you can see here, true north may be in a different direction, but they were benchmarks set up with a total station. And let's say that maybe the coordinates of this was 0, 0. It's kind of creating an assumed coordinate system. And this is the basic steps that the Champ tool does with the spatial adjustment in GIS. But I just imported these quickly just so you can see how they are oriented. I will quickly get rid of these and show off the Champ tool. Now the first thing we want to do is, we know the survey was done in NAD83 UTM Zone 12 North, so we're going to go ahead and set our data frame to that, and we'll go ahead and add a base map to help us out. And as that loads, here we go. Let's double check. Nope, we need to save it to UTM, apply, yes, yes. There we go. We'll kind of zoom into the Northwest United States. Now we can start the Champ tool, and the Champ tool is a free add-on. We're going to go ahead and set it to the NAD83 UTM 12 North. And benchmarks, I've already have them in this CSV file. It's expecting it in this kind of system with northing and eastings. So we have the 3 benchmarks that were set for the site, and what it's going to basically do, we're going to choose one benchmark, and it's going to do a rotation and a translation, basically a simple affine transformation, where it's going to translate it into a UTM space and then rotate it based on a benchmark that we choose as a hinge point, and then it'll rotate it by reference from the chosen benchmark into where it actually exists in the projection. So let's go ahead and choose and load the benchmarks from the file, and apparently have it open. So you can see the northings, the eastings, the elevations. It's projected. If we had bearing and distance, compass bearing and distance that we would taken from each benchmark, we could have put them there, but we don't. So we're going to go ahead and just choose our output workspace and total station transform. Now it's going to basically zoom in where those control points are in the UTM projection, and it's going to show all of the unprojected data we have, the hard lines, the topographic points. Let's go ahead and check what we want to bring in: hard lines, soft lines, topo points. And we're going to choose the unprojected control points, and it's going to, by the attribute field of the description, it's going to choose the BM, B1, BM, BM2, BM3, but these can all be set based on how your data is set up. So let's go ahead and say we're going to use benchmark 1 as our hinge point, and we'll just go ahead and rotate from BM1 to BM2, and just click proceed to transformation, and it'll take a couple seconds. Now you can see our data is there. We can zoom in a little closer. And now what these columns show is the residual errors from the BM to the BM that was rotated to, and then the third BM that wasn't used, but it's referencing and seeing what the residual errors is. So what you can do is you can click the benchmark and say we rotated to 3 instead of 2, and you can see slight shifts. And if we use 2 as a hinge point and rotated to the other benchmarks, or 3 as a hinge point. So I think the best one as far as residual errors looks to be this one. So we'll check this. Have we checked residual errors? Yes. Did we visually confirm? Everything looks good. So we'll save file and exit. And now it's going to create the feature classes of our unprojected data, which used to be kind of in a northerly direction, and now it's been translated and rotated based on assumed benchmarks, and it's been hinged and rotated based on the actual UTM coordinates of those benchmarks. So that's the basics of the CHAMP tool.